Good morning, class. Okay, so I'm not there today, and I don't have my picture showing because it's 3 o'clock in the morning, and I just got everybody back to bed, and I'm saving you that picture that you were about to see. Okay, so even though Mr. Mouse is gone, still rocking the awesome jokes. What did Mrs. Claus say to Santa Claus when she looked outside the window? Did you say it looks like rain, dear? Get it? It looks like rain, dear. Dude, it's like 3:30 in the morning and I still got these awesome jokes. Okay, moving on. So, we're not doing this. We already did this. We need to finish this and have this, and we're not going to get to that today just because I'm not there and I don't want to throw too much at you. And then Stuco kids, you are leaving today at 8:40. All right, let's go. Here we go. Completing the square. Remember, completing the square is used to find where the answers are on my roots of my graph. And I would like to know that for most quadratic equations, you're going to have two solutions. And that's if they cross up twice. And we already talked about they could have one, they could have imaginary. But most of them will have two. And sometimes it's easy, just like this when we did the factoring. And I wanted to know where did that quadratic intersect my x-axis at. And so the easy part would be what two numbers make 35 that add up to 12, right? And you'd be like, ooh, I know this, 5 and 7. Perfect. Then you'd have an x plus 5 and an x plus 7. Set that equal to 0. Solve for it. So we already did factoring. The only thing we didn't do was setting it equal to 0. This now tells me that I intercept my x-axis, which would be called my roots, are at -5 and -7 right there. So that would have been at -7 and that would have been at -5. So that's not completing the square yet. That's called solving by factoring, which is the first part of your homework. So here, solving by factoring, are there two numbers that make a -22 and add up to a 9? Hopefully you said, yeah, that'd be -11 and a +2. And then if you could rewrite it like this, you'd be on a good way, because if you FOILed it out, you would get this answer back. So this would be x minus 11 equals 0. X, ooh, that's plus 2 equaled 0. Therefore, x equals 11 or x equals -2. That means I would have crossed my graph at, let's imagine that's 11, and then at -2. And then it looks something like that. It's a big wide graph. All right, this next one, why don't you pause it and see if you can do. So did you find two numbers that made 33 but add up to a -13? Nope, I think this is then. Should be a then, huh? Alright, so when you have problems like that, factoring is not always going to work. So you're going to have to do something different, which is called completing the square. Completing the square happens when a perfect square trinomial cannot be factored. Or it can happen on any one. We can manipulate it. So what you do is you find 1/2 of b, you square the results from step 1 and add that to the equation of ax squared plus bx. And you're like, I kind of did that on my homework. You did. So for example, it was like this. Ax squared plus 8x plus c. And I said, what would c be in order to make a perfect trinomial? So you said 1/2 of 8, which is 4, and then you squared it. So you said 8x plus 16. 1/2 of 8 is 4. 4 squared is 16. Here was another example. X squared plus, let's go 24x. What does my c have to be? Well, 24 divided by 2 is 12. 12 squared is 144. That's the first step in order to complete the square, and then the rest I will show you here. So for example, we just did that one, didn't we? We would say this was, no we didn't, we did 24. Half of 12 is 36. Now by doing that, reminder, you could rewrite that perfect trinomial like a x plus 6 squared, and that's how we would factor it. Okay, that was from last time. One more. Let's go x squared plus 10x. I would say half of 10 is 5. 5 squared is 25. So if I wanted to factor it, this would look like x plus 5 squared. There we go. Come on, push the play. Oh no. Oh no. Oh no. And guess what? It's too late out. I really don't want to redo this. So bear with me because I am not. Come on. Come on, pin. Okay. So on this one, we write the trinomial as a perfect square. This right here, did you say 49? And so it would be x minus 7 squared. That's just a review from last time. Now, here we go by completing the square. If you notice, this is not a perfect trinomial. Half of 20 is 10, and 10, or half of 20 is 10, and this is not 10. So what they did is they moved this 20 over to the other side by adding 20 to both sides. And then they started and they said half of 8 is 4. 4 squared is 16. Well, if you add it to the left, you have to add it to the right. So if x plus 4 squared equals 36, that's all because I added those together. So they're like in a factor mode. Well, if I take the square root of both sides, that gets rid of my parentheses. X plus 4 equals plus or minus 6. And this is what we did the day before because we solved the quadratic by taking the square root method. So let's try another problem. Let's see if it's a perfect try. Half of 24 is 12. No, didn't work. So now I'm going to do it by completing the square. Subtract 24 from both sides. You have x squared minus 10x plus something equals negative 24. Now, half of 20 or half of 10 is 5. 5 squared is 25. So I'm going to add 25 to both sides. Now I can factor it and I can say x minus 5 squared equals, this would equal to a positive 1. Take the square root of both sides. So I have x minus 5 equals plus or minus 1. Therefore, x equals negative 6 or positive negative 6. That's not negative 6, Raffle. Get it together. Add 5 to both sides. X equals a positive 6 or a positive 4. So that's what my two roots would be. We're on the x-axis. One more. Going here, subtracting by 9. X squared plus 10x plus something equals negative 9. Add 25 to both sides. Now, if I do my perfect square, remember I got 25 because I took half of 10 is 5. 5 squared is 25. I would have an x plus 5 squared equals, this time I'm going to have a 16. Take the square root of both sides. X plus 5 equals a positive or negative 4. Subtract 5 from both sides. You're going to have x equals negative 9 or x equals negative 1. Anytime you want to, you can always pause me and rewind. That's the beauty of this. Okay, so now we have it where an equation is not a positive 1 for a, which you're going to get an ugly number, people. Okay, let's just get that out of the way. So what they did here is, in order to make that a 1, they divided everything by 2. Notice it becomes some beautiful fractions. I would keep it like fractions. Same part. Subtract 3 over 2 on both sides. And that's how they got this answer right here. Then they took half of 5 over 2. So if you take 1/2 of 5 over 2, it's like multiplying it by a half. And that's how they got 5 over 4. So when they did that, they did that on the other side. They have to have like denominators. So after they got like denominators, that's what this became. Or you just put that in your calculator, either one. Then I take the square root on both sides. And if I had this as a fraction, that would be 1 over 4, because the square root of 1 is 1, square root of 16 is 4, plus or minus. And then they added 5/4 to both sides. Again, calculator, or just plug and chug, and this is what you would have gotten. It's no different. It's just a fraction. It's going to be okay. I try not to give you too many of those on your homework today, though. Alright, should we try this? Again, 3 o'clock in the morning. Let's see how this rocks and rolls. This is going to be ugly because I don't have a calculator. Not that I need a calculator, but I'm not going to lie. I kind of want to make this like a fast PowerPoint. And so x squared plus 10 over 3x. I'm going to add 8/3 to both sides. Okay, so 1/2 of 10 over 3 is 10 over 6. So if I add 10 over 6 to the left, I have to add 10 over 6 to my right. Oh, and then I gotta square it. Oh. So 10 over 6 squared, because that's not right, would be 10 over 36. So that means I have to add 10 over 36 to both sides. So this side would become 10 plus, or x plus 10 over 6 squared equal, Lord have mercy, I gotta take this times 12 and this times 12. So then I'd have 36 plus 100 over 36. This is what you get to watch Miss Bratfold struggle. Yep, it's okay. Alright, so I would actually have 196 over 36. I know that reduces down. I'm not reducing it down right now. I want to take the square root. I want to say x plus 10 over 6 equals the square root of 196 over 36. Again, I know it reduces down. It's going to be a plus or minus of it. I'm going to minus 10 over 6. Now, if I had my calculator, we'd rock and roll. I don't want to figure it out and make a video that's 100 minutes long. So I would say negative 10 over 6 plus or minus this. And I have faith that you guys can all figure that out. Okay, so that's like the second part of your homework. Yeah, we're not going to do that again. So how would you solve? That's all good. So that's it. Okay, so your teacher is going to pass out a worksheet. I want you to do numbers 1 through 10 on the factoring side. So reminder, those are the problems like this. X squared plus, let's say, 9x plus 20. And you are like, always check this right away. If it works, which would be beautiful if it did, because that means it's going to be an awesome answer like that, then you're going to work these out and you're going to say it like that. Or on the back side, you're going to have problems I want you to do by completing the square, what we just did, and do numbers 1 through 10. Always check to see if you can do it like this method right here, completing this, or instead of completing the square, factoring. If not, if it's like a problem like this, and it's x squared plus 11x plus 13 equals 0. There's no numbers that multiply to 13 to get to 11. So reminder, these are the ones where you're going to have to go like this, what we just went over. Okay? And she also has an answer key that you can rock and roll with. Alright, good luck.